Okay, let's go. So what was good is most of you know how to do this one. So for A, we need to find the derivative.
It's going to be 2x minus 6.
2x minus 6. That was excellent. B, we need to find the gradient of the tangent at x equals to 1. So into the derivative is important. So we put this into the derivative. Most of you manage this one. Then things go badly wrong from this point onwards. There's some knowledge in bits and pieces. So for C, we need to find the gradient of the normal line. So firstly, this is a normal line. So what's the gradient of the normal line going to be? The gradient of the normal line is going to be 1 over 4. We need the negative reciprocal of the tangent. We need the negative reciprocal of the tangent.
We get 1 point.
That's 1 point.
Okay, so it's going to be 1 over 4x.
No, 1 over 4. Don't bring the x into it. When you're talking about the gradient, don't include the x.
No, ever. I'm just saying because ax plus by.
No, not quite, because we have this different form. So next, in order to get the equation of a straight line, you need a point. You need a point. We don't have a point. We know that x equals 1. We need to find the y value. So the y value, if you remember for last class, is given by the original function. So y is equal to f of 1. If we put this into this function here, we're going to get 1 minus 6 plus 5, which is 0. So the curve goes through 1, 0. This is a coordinate. We put all three of these numbers, quarter, 1, and 0, into the equation. We get y minus 0 equals 1 over 4 x minus 1. To get it into this form, you have to have it as an integer. It says here, this form always requires integers. So we have to get rid of that 4 in the denominator. We multiply by that 4, we'll get 4y, and I'll get rid of that 0 now. And then we open up this bracket, x minus 1. So rearranging that into the form that they want gives x minus 4y minus 1 equals 0. I'm sort of moving the 4y to the right, but then writing it the other way around. Okay, Lorenz, on yours, you get this answer to get no points. Because this is wrong here. These are on the ground. And then, when you follow through and do a quarter times y, you get 4y. So that algebraic expression, it leads to the right answer. So this type of a solution is you only get 1 point here for this. This is wrong, even though you get the right answer, because your solution is wrong, you won't get the point.
So I would start mark 7 get 1.
Yeah.
Splendid.
No, sorry, you will get 2. You might get it for this one also.
Okay, that's twice as better.
Yeah, you have the wrong solution. You do really want to have the ability to move away from using polynomials, and it's supposed to be you're so faithful to the solution, and often that you don't get it right. These are actually used that you can show here. It's easier to decide. Okay, let's have a look at B. So, we went badly wrong on this one. So, a lot of people managed to get 1 point. So here for A, we need to set the derivative equal to 0 and solve. So you're not going to get a point for this. You have to actually solve this. This is a quadratic equation. If you put it into n solve, you're going to get x equal to 0 and you're going to get 1 point. But you've got to find the other solution. You've got to find the other solution. You can see it's a quadratic. You should know it has 2 solutions. And then you should go look for the other solution. The other solution is going to be x equals 4.
I wrote my answers, they're correct, but I just wrote them like this. So would that make sense?
You might not get it because we are asked to solve the equation. It's not in two variables, it's one variable.
Okay.
So you might get 1 point. Some mark schemes might not give you the point for writing coordinates instead of actually knowing it's supposed to be the x value.
Because I just put it in my.
Okay, I'm going to have to explain a little bit. I want to teach a bit before we do question B, because you guys didn't have a clue here on this one from what I saw. So let me just go over to here, add a slide.
So straight.
Okay, so we have a curve that looks like this. And we consider the tangent to the curve. If I draw a tangent to the curve here, that's a straight line. What will the gradient of that straight line be? Maybe 1? Could it be anything else? Could it be 2? Could actually be n. It could be a range of values. Plus we have no scale here. So it could be 1,000, it could be a half. There's no scale, so we can't really tell. But what we do tell is it's going up. The curve is going up. So the gradient has to be positive. So here, all we can tell is that it's going to be positive, going up, and it's going to be steeper here than there. Because I've got no scale, we can't really tell the exact value. We know that this is positive, and this one is more positive than that one.
Would it be infinity?
No, definitely not infinity. That would be a vertical one. So here at this point, what is the gradient of this tangent going to be? 0. Here at this point, what can we say about the gradient of the tangent there? It's negative. Why do we know it's negative? Because it's going down. What about here at this point? Here it's 0, isn't it? Here it's going to be 0. And over here? Positive. So, here it's positive, here it's positive, here it's 0, here it's negative, here it's 0, here it's positive. The gradient. What could we say about the derivative here at this point? It's going to be positive. Why? The derivative is the gradient. Where is the derivative going to be negative? When the slope is decreasing? Which is where? Between the two zeros. If this is the graph of y equals f prime of x, this is the graph of y equals f prime of x. This is a hard question. This is the graph of the derivative. When is this function rising? No. This is not the graph of the function. You don't see the function. You're looking at the derivative. When is the function y equals f of x, which isn't drawn, when is this function rising? What's the interval?
From 3 to negative 3 to negative 1.
So Leo says that this implies that f of x is rising in this interval. She's correct. Explain to the person next to you why she's correct. Okay, so the derivative in this interval is positive. That means the function's going up. The derivative here is negative. That means the function's going down. The derivative here is negative. That means the function's going down. The original function is going down here, and the original function is going up here. Do we see it? Which one of those two is a maximum?
The green.
No. The original function has a maximum and a minimum. The original function has a maximum and a minimum. Where is the function's maximum? No. You're looking at the derivative.
When the derivative is equal to 0.
When the derivative is equal to 0. Good. So that means either minus 1 or minus 3. Which one's the maximum?
No, 3.
Picture in your mind a maximum.
3.
Does the function go up and then down, or does it go down and then up?
Up and then down.
Picture a maximum in your mind. Does the function go up and then down, or does it go down and then up?
Up and then down.
It goes up and then down. Which one of those is the maximum?
-3.
You have to.
Shush. -3.
Because it starts that way.
How do we know it starts that way? Maybe it started
Because
this
it's
way.
started the outside really down.
What does the green shading mean?
It's so zero.
It's going up. What does the red shading mean?
Going down.
It's going down. Because the derivative value is negative, it's going down. When the derivative value is positive, it's going up. So we want one of these points. We want one of these points where the derivative is 0, because that's a maximum or a minimum. We want our maximum to be going up and then down. Where is it going up and then down?
Both -3 and negative 1. You're not doing this.
2 because the peak of the.
Okay, negative
That's the
3.
point of inflection. There at 2, the derivative has its maximum. That's when it's increasing most rapidly.
From -3 to -1. Like this.
It's increasing.
Yeah, but.
Where is the maximum?
Negative 3.
Negative 1.
The maximum is at -1.
Yes.
This is a maximum. This is a minimum. This is a minimum. The original function is going to look something like this. The function is going down, we have a minimum, then it's going up, we have a maximum, and then it's going down. This derivative tells us that the original function is going to look like this. I can't tell you whether it's up there or whether it's down here. But I can tell you the shape and I can tell you where the maximum and minimum are. The reason I can't tell you this is that plus c when we integrate. We don't know about it. But we can say, look at this is the original graph now. So we'll say this is the original graph, y equals f of x. Here it's going down. The derivative is negative. Here the function is going down, the derivative is negative. Here the derivative function is 0, the derivative is 0. Here the function is going up, the derivative is positive. Here the function reaches a maximum, the derivative is 0. Here the function is going down, the derivative is negative. So let's have a go now, just to finish off at that last question. So we only have the derivative. We only have the derivative. Graph the derivative. On your calculator, graph the derivative. The derivative looks like this. When is the derivative negative?
From 0 when it's under 0.
From 0 to 4. If the derivative is negative, is the function increasing or decreasing? So, BI, the answer is
More than or equal to, no?
no. From 0 is less than x is less than 4, we can see on the derivatives graph that the function is decreasing.
Oh, but either way, it's not really, yeah.
When is the function increasing?
From 4.
But also
But also from 1 onwards. Infinity
negative.
to 0.
Ooh. No, where's my pen?
Well, it's not English, it's not Arabic, it's not
So we could write it like this, or you could write it as x is less than 0, or x is greater than 4. That question was actually really easy, but you've got to get the concept of the derivative. It's a hard concept to get your head around. So when we look at this graph, we're not looking at the function, we're looking at whether the function is going up or down. These 2 points are interesting. So these 2 points, which one of these is the maximum? Is the maximum at 0, 2, or 4? Picture the maximum in your mind. It has to go up and then down. And well, it has to go up, 0, and then down.
0.
Why?
Because it's like.
Why? Because it's
It's decreasing the derivative side up.
no. The derivative is positive here. So he's right. 0 is where this is a maximum. The derivative is positive. The graph goes up. The derivative is 0. The graph goes flat. The derivative is negative. The graph goes down. That's a maximum. The original function has a maximum at x equal to 0. All right, that's it for me today.